Math 100, Lesson 6.5, a general factoring strategy. So we've really learned everything we need to know about factoring, and now we just have to put it all together. So anytime your directions tell you to factor completely is usually what it will say. The first thing that we always look for is the greatest common factor of all the terms. Okay, once we've done that, the next thing we look for is any special forms like we talked about in 6.4, perfect squares, perfect cubes. Remember, there is only a rule for difference of squares, but there is a difference and sum of cubes. Are there 4 terms? Because that means we might need to factor by grouping. Is it a trinomial? That's where we'll look for 2 things that multiply to be AC but add to be B. Once we've decided that, and we do the factoring that we can do, the last thing we need to always double check is make sure that all the factors that we came up with cannot be factored more. Because we do need to make sure that our problem is factored completely. All right, so our directions here are factored completely, and we're just going to work some problems to make sure we understand what that means. So, factor completely. Didn't turn out so good. Okay. All right, so on this particular problem, step number 1, we always look for the greatest common factor. Oh, there is one. All right, it's 5x squared. So we're going to go ahead and factor out our greatest common factor. When I factor it out, I would be left with x squared minus 9. Now, I need to notice that that is difference of squares. Okay, this is where we have to pay attention to our factors and see if there's anything else we can do. So this 5x squared comes down. We don't do anything with it. But then we factor the x squared plus 9 would be x plus 3 and x minus 3. Now we have factored completely. Excuse me. All right, let's try another. So again, first thing we look for, greatest common factor. There is one. Okay, 4. We'll go into all of these numbers. So I'm going to first factor out 4. Okay. And then I need to make sure, are all my factors, are they finished? They are not. I have a trinomial here. And so I need to factor that trinomial. I'm looking for 2 things that multiply to be AC, 2 things that add to be B. So I need to know, what are A, B, and C? All right, my A value, now we're only looking in parentheses here. My A value is 1, my B value is -4, and my C value is -12. So A times C is -12. And my B value is -4. So looking for 2 numbers that multiply to be -12 but add to be -4. So those would be -6 and +2. And you can either do grouping or faux fractions. I prefer faux fractions. I take my A with X, put it over one term. My A with X, put it over the other term. If they can simplify, you do. In this case, they cannot. I'm ready to write my factors. I do need to hold on to this 4. It's still there. And then my factors are x minus 6 times x plus 2. So all of that is my answer. That is factored completely. All right. So again, first we look for our greatest common factor. There is one. It is 4x. So I'm going to factor out 4x. I'll be left with x squared, x to the 4th, minus 16. Check to make sure that things can't be factored. Oh, there we have difference of squares. So I need to factor that. My little 4x comes down. And I would get x squared, a plus 4, and a minus 4. Again, I look at all my factors. Am I finished? Oh, guys, guess what? I have difference of squares again. There is no rule for sum of squares. So this 4x comes down. This x squared plus 4 comes down. But this x squared minus 4 can be factored into x plus 2 times x minus 2. Now we are finished with that problem. So we really have to be careful, make sure that we're finished with a problem. That's what I typically see. People are telling me all the time when they do their homework from this lesson, I'm pretty sure I got it right, I think they're doing something wrong, and it usually works out to be you just didn't finish factoring. So make sure you double check and see if you can factor any more. All right, let's try. All right, so we look for our greatest common factor. Oh, in this case, there is not one. Okay, it's the first one we've done so far that did not have a greatest common factor. So now look for special forms. There's no difference of cubes, no difference of squares, no sum of cubes. It does have 4 terms. So I am going to group. Okay, when I see 4 terms, I know I'm going to try to group. Okay, so now these two do have a common term, and it would be x squared, and I'd multiply and get x minus 4. Okay, my last group has a negative 9 in common. When I divide that, I get x minus 4. So now my two groups have an x minus 4. It gets factored out, and I multiply by what is left, x squared minus 9. And so I feel like I'm finished. And so this is where I go, wait a minute, are all my factors done? Can they be factored anymore? And this one is difference of squares. So I can do some more. My x minus 4 comes down, but x squared minus 9 factors to be x plus 3 times x minus 3. So there would be my answer. All right, so if you've done the homework for 6.1 through 6.4, you have found that sometimes when you're factoring, you get something called prime, and that just means it cannot be factored. Not all problems can be factored. Now, that should never be the first thing you think of. Oh, I can't figure it out. It's got to be prime. But that is a possibility, is that an answer could be prime. It could not be able to factor at all. Let's try this one. Again, we're looking for a greatest common factor. There is one. It is 6x squared. When I factor it out, I'd be left with x squared plus 25. And this is where I ask myself, can I factor any more? Are my factors finished? Are they done? They are done. There is no rule that says we can factor x squared plus 25. Okay, that's a common mistake. We are finished. That's all we were able to do there. Sorry, I changed my mind. I'm going to change that to a different one. Let's do y squared plus 8y minus 16. All right, so I look for a greatest common factor, and there's not one. So then I look for special forms, and this is a trinomial. So I'm looking for two things that multiply to be a times c, that add to be b. So negative 16 is a times c, and my b value is 8. So I'm looking for two things that multiply to give me negative 16, but add to give me positive 8. Now, 4 times 4 is 16, and 4 plus 4 is 8, but the signs are going to mess me up, because positive 4 times positive 4 will not give me negative 16. So this is an example of this is prime. It absolutely, there are no numbers that work out to be that value. So it would be considered prime. Okay, let's do another. So again, we're looking for difference of, we're looking for our greatest common factor. There is one. It is 2x squared. When I factor that out, I would have x cubed plus 27. Now hopefully you notice 27 is a cube. That's the exact problem that we did in our notes for 6-4. So this is difference of cubes. So this is where you need that little set of rules beside you for difference of cubes, unless you memorize those rules. So we need to know the a value and the b value so we can plug them into our rules. A is x, and our b value is 3, because 3 cubed is 27. All right, so this little 2x squared is going to stay here. And my rule says I take a and I add to it b, and then it says a squared minus a times b plus b squared. So all of that would be my answer. So we've done 7 problems with factoring. In section 5 that's just all it is. It's just, you're just going to have several different problems all mixed up, and you're going to have to be asked to factor. So you have to decide, oh my goodness, which one is this? So make sure that every time you go through the process, look for the greatest common factor first. Then you look for, do I have difference of squares? Do I have difference of cubes, sum of cubes? Is it a trinomial? Are there 4 terms so that I can group? And then at the very end of your problem, always make sure you ask yourself, can any of my factors be factored anymore? Are they finished? And then sometimes there are those problems, like number 6, still on the board, that cannot be factored, and we call those prime. Those do not happen often, but they do happen. All right, so that is it for section 5.